Geometry and trigonometry. Split into 2 days. Today we're talking about lines, triangles, arcs, and sectors. So that was technically part 1. We first went over this last year. And then next week, we're going to be talking about Bernoulli diagrams and surface area and volume. So basically part 2. All right. If you do have your notes, it'll be good to kind of look at them so you can have this like side-by-side type thing. Okay. Linear graphs. Okay. You'll need to know how straight line graphs work, how to graph them, the meaning of y equals mx plus c, how to find gradient and y-intercept. What is y equals mx plus c?
So equation of a line.
In what form?
Gradient-intercept form.
In gradient intercept form. Okay. Where m represents your what?
No.
And c represents your what? Very good. That ain't changed since pre-algebra. Okay, it's still very much the same. How do you find the gradient if you're given 2 points?
Do the change in y over the change in x.
And how do you find the change in y over the change in x?
y2 minus y1 over x2 minus x1.
So if you're given 2 points, you'll need to find the gradient by doing y2 minus y1 over x2 minus x1. I believe that's in your reference book and prior knowledge, but don't quote me. But, okay. And then after you find the gradient, you'll essentially need to use a point and then plug it in to find your c, your y-intercept. Okay. Now, that's one way to do it. Using the gradient intercept form, plugging it in for y and x and m and finding c. But then there's also 2 other ways to write the equation of a line. There was point slope or point gradient form, and then there was standard. Okay. Who remembers what point gradient form is?
Y minus y1 equals x.
Again, m is still your gradient, and x1, y1 represent one of the points. Anybody remember what standard form is? Zero equals? Close.
Isn't it ax plus bx equals c?
Y
Plus c.
D. That was standard form. A lot of times they would give you a problem that would say write it in this form where A, B, and D were elements of integers. And so you had to be able to go from whichever form that you wrote your line in, whether it was point gradient form or gradient intercept form, and then transition it into standard form. Remember, integers are what types of numbers?
And any whole number that's positive or negative.
Any whole number that's positive or negative. So if you ended up getting the equation of the line to be 1/2 x plus 7, and you had to write it in standard form, how would I do that? How would I do that?
Set it equal to 0.
How do I set it equal to 0? Move the y over, that'd probably be the easiest. So that turns into 0 equals 1/2 x minus y plus 7. But are these integers? Not that 1/2. How do I make it into an integer?
You have to flip it and change the sign.
Not flip it and change the sign. I think you're saying something different. You would want to multiply every term by the denominator. That's how you turn a fraction to a whole number. Because what's 0 times 2? 0. What is 1/2 times 2? 1. No more fraction. Then it'll be y times 2, so it'll be -2y, and then 2 times 7, which will be 14. That's how you get it into standard form. So if you found slope intercept form to be 1/2 x plus 7, I just made that up. And you had to write it in standard form, which a lot of you guys had difficulty with when we first did this. That's how you turn a fraction into a whole number. That's how you get it into standard form. All right. All right, let's take a look at this example. All the examples that we do today, I pulled from an old, not too old IB exam, at least within the last 5 years, okay? So it says the gradient for a safe descending wheelchair ramp is -1/12. Now, mind you, this is actually, as you can see, a part C, so there was an A and there was a B. Like you were given, I think, another diagram that you had to find the gradient for, and then you had to determine if that particular wheelchair ramp was safe, knowing this information. But I went ahead and took that out and I gave you this instead. I said the equation of a second wheelchair ramp B is 2x plus 24y minus 1920 equals 0. And then they give you an image. It says determine whether the wheelchair ramp B is safe or not and justify your answer. How would I go about determining if the wheelchair ramp is safe?
Finding the gradient.
Finding the gradient. All right. How do I find the gradient of that line?
Well, it's in standard form. So you have to put it in some kind of, I guess we'll do point intercept or gradient. Yeah, point gradient.
No
No,
point.
no, slope intercept.
There you go. It is in standard form. Standard form, we can't see the slope right away. But if we put it into gradient intercept form, then we'll definitely know what the gradient is. Remember, gradient intercept form is y equals mx plus c. So that means you have to isolate y in this equation. Dylan, how do I isolate y?
You divide y, you subtract 24y to the other side.
Okay. Subtract 24y to the other side.
Divide 24 on both sides.
Just 24.
The negative 24.
The negative, there we go, okay? So I'll have 2 over -24, that reduces to what?
-1/12.
So it becomes 1/12x, a negative and a negative make a positive. What's 1920 divided by 24? Okay, this is 80 equals y. So now we are in gradient intercept form. So this is the work to help us justify, is the wheelchair safe or not? Yes, and the reason is because the gradient is -1/12, and it said that it's safe if the wheelchair ramp's gradient is -1/12. So we're good. Now, mind you, IB problems, y'all should know by now, they incorporate multiple, well, some questions can incorporate multiple pieces of our curriculum. And so whereas CI asked you essentially to deal with equations of lines, CII is asking you for to find the horizontal distance of the wheelchair ramp. B, the horizontal distance from this wall to the ground. How do we go about finding that distance? Any suggestions?
This is when that triangle stuff comes in, right?
Possibly. That triangle stuff. You Tola?
Yeah, I don't know how to do that though.
Well, we're definitely going to go over, but we actually don't need that for this. This 0 indicates what?
Zero distance.
True.
The y-intercept and the x-intercept?
You got a y-intercept and you got well, not a y-intercept, but you have a point here. And that represents 0, 0. So this is your y-axis, this is your x-axis, and this point would be your x-intercept. So if you can figure out what this point is, let's just call it A, then you'll be able to figure out the horizontal distance of the ramp. How do you find an x-intercept in general?
You plug in 0 for y.
You plug in 0 for y. So you can't forget about that. How do you find a y-intercept? Plug in
0 for x.
Plug in 0 for x. That's how you find a y-intercept. So you have to be able to recognize that based off of this diagram, okay? So let me erase this in case you didn't see it. This was like essentially a first quadrant, and then the ramp was just coming down from the y-axis to the x-axis. So I'm gonna plug 0 in for y. And then I'm gonna solve. So this becomes 2x minus 1920 equals 0. How do I solve for x?
You add 1920 and then divide by 2 on both sides.
Add 1920 divided by 2 on both sides. And what's 1920 divided by 2? So then the horizontal distance is 960 centimeters. Don't forget your units. You can't forget about parallel and perpendicular lines. They also came into play with equations of lines. You need to know how to work with lines that are parallel to each other, same direction but never meet, perpendicular to each other. Remember, perpendicular means they form a 90-degree angle. However, neither of those two things in parentheses is going to help you when it comes to writing an equation that's parallel or perpendicular. You essentially need to know that parallel lines, what do you know about their slopes?
They're the same.
They have the same slope. So if you're given a line and you find the slope or the gradient of that line, you know the gradient of a line that's parallel to it. What about perpendicular?
They're opposite slopes.
They're opposite, not just opposite, but they're opposite reciprocal. Reciprocal. So one slope that you found was 2/5. What would be the slope of a line that's parallel?
2/5.
Parallel, 2/5. Gotcha there. But perpendicular, it would be what?
-5/2.
-5/2. And then you use that slope and then whatever other point to actually write the equation of the line. Let's take a look at this one. I'm going to let you guys do this on your own, okay? Because I've already reviewed a tad bit here. And then for A, you can use your reference booklet because that formula is in there. All right? So I'm going to give you 5 minutes to do this problem that's on the board, and then I'm going to check in. The diagram shows a straight line L1, which intersects the x-axis at A, -8, 0, and the y-axis at B, 0, 4. Write down the coordinates of M, the midpoint of the segment. Let me hear from somebody online. What were the coordinates of M?
-4, 2.
-4, +2. Very good. Remember, midpoint is nothing but the average between the x's, the average between the y's. So that's -8 + 0 divided by 2, and then 0 + 4 divided by 2. Very good. Then in the classroom, it's asked me to calculate the gradient of L1. What'd you guys get for the gradient? 1/2. Very good. Using the formula, y2 minus y1 over x2 minus x1. That'd be 4 over 8 because 2 negatives make a positive, and that does reduce down to 1/2. Wonderful. The line L2 is perpendicular to L1 and passes through the point 1, 2. If it's perpendicular, then
The slope is opposite reciprocal.
which will be what, Michaela?
-2/1.
Very good. So -2/1 is what?
-2.
Thank you. -2. So I'm going to use that slope and that point to write the equation of L2, giving my answer in the form of y = mx + c. Who can walk me through that?
You would plug in.
Go ahead, Michaela.
Okay. You would plug in -2 as your slope, and then you would plug in the points they give you. So it would be 2 = -2 times +1 + c. You add 2 on both sides, and then you'll get 4 = c, and then it should be y = -2x + 4.
Yes? Awesome. Pretty easy, right?
Wait, will we simplify? Oh wait, never mind. No.
And we'll be done there because it asks us to give us in that respective form. So we are good. All right. Take a look at this one. This one was a little longer. It actually was longer than this. It actually had a D, E, and an F, so it was a paper 2 type question. But the D, E, and F incorporated some other things that didn't involve lines. So, but I wanted just to keep these questions just to lines, okay? The following diagram shows two triangles, OBC and OBA on the set of axes. C lies on the y-axis and O is on the origin, okay? The equation of the line BC is y equals 4. Remember, y equals a number is how you write the equation of a horizontal line, like a horizontal asymptote, right? So if that's the case, then what's the coordinates of C?
0.
Exactly, because it's the y-intercept. And if the equation is y equals 4, it's hitting the y-axis at 4. Then it tells you that the x-coordinate of B is A. What's the y-coordinate?
4.
Very good. You know it's 4 because it's on the line y equals 4. You just don't know what the value of x is. Oh, I didn't even look at BI. It asks us to write down the coordinate of B. It is A, comma, 4. And if that's the case, you have to write down the gradient of line OB. O has coordinates what?
0, 0.
0, 0. And B, even though the x coordinate is a variable, you can still find the gradient. Just use the formula, okay? y2 minus y1 over x2 minus x1. So what will be the gradient of OB? 4 over A. It's an expression. It is an expression, all right? And in part, I think it was part E, it actually to find the value of A, but there was other things that were involved to get to that point. All right, I just want to make sure that we're good on this part. Don't forget, write down little work to no work needed to answer these questions. Point A lies on the x-axis and the line AB is perpendicular to OB. If it's perpendicular, then what is the gradient of AB? Negative A over 4, because you do the opposite reciprocal. And if that's the case, how do I show that the equation of the line AB is this expression?
And, slope intercept form, then we can just set it up to standard.
Yep, we could write in slope intercept form and then change it into standard, because that is a variation of standard form because it's equal to 0. So to write the equation of a line, I need 2 things. Gosh, I don't know how many times I've said it. To write the equation of a line, we need 2 things. What are those 2 things? Not
A slope intercept,
a slope and a
y-intercept.
coordinate, really and truly, because we're not always given the y-intercept, but we can always find it. So we really just need a point and a slope. So I have my slope, which is here, and I need a point that's on AB. What point do I know? A4. So then if I use that point with that slope and slope intercept form or gradient intercept form, then I can find my y-intercept and then put it into standard form. So I plug in 4 for y, negative A over 4 for M, and A for X. Now that A is A over 1 when you're multiplying, so calculator is not really going to help you here. So what's negative A over 4 times A over 1? Very good. So then C is going to be 4 plus A squared over 4. That's the value of C. So my equation in gradient intercept form is going to be y equals negative A over 4x plus 4 plus A squared over 4, because that 4 plus A squared over 4, that's my C. My M is negative A over 4. Now it says specifically I have to show that it's this equation. So how could I do that? How can I transform what I have now into that equation?
You have to get rid of fractions, so you have to multiply by 4.
I have to multiply everything by 4 to get rid of the fraction. So that becomes what?
4y
4y
equals ax plus 16 plus ax, oh sorry, a squared.
Exactly. Because you multiply by 4 to get rid of those denominators. So that negative ax stays, that a squared stays, and that 4 turns into a 16. Then essentially, what will I need to do?
Move the 4y over.
You have to move the other side over.
I got to move the right side over. So that means I have to add an ax to both sides. I have to subtract the 16 to both sides. And I need to subtract an a squared to both sides. So then that way, I can get it so that it looks exactly what I have. So that's 4y. There's that plus ax. There's that minus a squared. And then there's that minus 16. And that is how we show.
So I'm not sure what number it was, but you did 4 equals negative a over 4, and you put an a in the parenthesis. Why'd you put a instead of x?
Because back in here in this point, we were trying to find the value of c. So remember, when we're trying to find the y-intercept, we take a point and plug it in for x and y. And then we essentially solve for c. So I plugged in a for x because that was the coordinate that I was using.
Oh, okay, thank you.
No problem. And then I plugged in 4 because that was my y coordinate. So I was trying to find my c. One more thing with lines that we'll talk a little bit more about when we go over Bernoulli. Remember, a perpendicular bisector is a line, array, a segment that cuts another line or segment into 2 equal pieces and forms a 90-degree angle. When you are trying to find the equation of a perpendicular bisector, which we do in Bernoulli diagrams, you want to find, of course, the slope, which the slope of the perpendicular bisector, which is equal to the opposite reciprocal of the line that is bisecting. So you technically would find the slope of AB, and then you do the opposite reciprocal to get this, the slope of the perpendicular bisector. And then the point that you would use would be the midpoint of AB. And then that's what you would use to write the equation of your perpendicular bisector. Again, you need a slope and a point to write the equation of a line. So for that perpendicular bisector, you do the opposite reciprocal of AB to get your slope, and then you do the midpoint of AB to get the point that you would use. But we'll talk about that a little bit more in detail when we go over Bernoulli diagrams in part 2 of the review. Right triangle trig. When you have a triangle, there's a 90-degree angle. It's much easier to use Pythagorean theorem and then SOHCAHTOA to find the equations or the lengths of side lengths or angles. Remember, a right triangle, you know it's right because it has a what?
A right angle.
A right angle, that little box. The side opposite of that 90-degree angle is called your what?
Hypotenuse.
Hypotenuse. And then hypotenuse. And then from there, you would label your other 2 sides as opposite and adjacent depending on where theta was. Okay? So if theta was down here, then this would be your what side?
Your opposite.
And this would be your, and of course that changes depending on if theta is at the top. Okay? So you always want to make sure that it's always based off of wherever theta is, one of your acute angles. We never do SOHCAHTOA with using 90 degrees as my angle, okay? And if you're like SOHCAHTOA, Ms. Anderson, what's SOHCAHTOA? That was the thing that you learned back in geometry to help you remember the ratios between sine, cosine, and tangent, okay? Sine of your angle was your what side over your what side?
Opposite over the.
C stood for, so the cosine of your angle was equal to what over what? And T stood for tangent, which was what? Okay. And then that's what you'd use to set up the equations to find side lengths or angle measures in a right triangle. Remember, theta was always acute. It was always one of your acute angles. Always acute. What is Pythagorean theorem?
A squared plus B squared equals C squared.
And C represents your what?
Hypotenuse.
Always. When did you use Pythagorean theorem?
Find side lengths,
When you know.
2 of them.
Exactly. You use Pythagorean theorem when you knew 2 side lengths and you were looking for a third. You would use SOHCAHTOA if you knew either 2 side lengths and you were looking for an angle, or if you knew an angle and a side length and you were looking for another side length. Okay. There was also this concept of using the inverse. Okay, like when you would type second sine and this popped up. When do you use the inverse? Who remembers, when would you use the inverse of a trig function? To find an angle. So whenever you knew 2 side lengths and you were looking for the angle, you would use the inverse of the trig function, and then of course your ratio. So I remember some students that have issues with that. You use the inverse when you're trying to find an angle. So let's take a look at this. I think this was actually from 2019, okay? Gunter is at Berlin airport watching planes take off. He observes a plane that's at an angle of elevation of 20 degrees, where he is standing at point G. Remember, angles of elevation always come from some horizontal line looking up. So this will be considered your angle of elevation. What was it called when it looked down? Your angle of depression. Okay, but it always came from some horizontal line going up or down. So if Gunter is represented by G, that horizontal represents the ground that he's standing on. And then he looks up to the plane. And so that is your angle of elevation, which is 20 degrees. The plane's at a height of 350 meters. This information is shown in the following diagram. I put both diagrams because this took up the entire page on the paper that year. So you'll need the triangle on the left to answer part A, which is to calculate the horizontal distance GH of the plane. Give your answer to the nearest meter. So if I'm looking for this is a right triangle, 20 is acute. I'm gonna have to use SOHCAHTOA to find GH. And I use tangent. Why do I use tangent, Jana?
Because you're not using your hypotenuse.
Because I'm not using my hypotenuse. Don't make it hard on yourself. So I set it up. Tangent of my angle, which is 20, equals my what over what?
Opposite over adjacent, so it's gonna be 350 over x.
Opposite over adjacent is 350 over x, or you can even put GH. Me personally, I'll probably put GH because I had to do it multiple times or use the same triangle multiple times. You know, you don't want to say x for everything. How do I solve for x?
You divide 350 over tangent of 20.
I would divide 350 by the tangent of 20. You multiply both sides by x to get x out of the denominator. And then I would divide both sides by the tangent of 20. So type that into your calculator, making sure your calculator is on what?
Degree.
Degree. When you sit for your exam, your calculator will be reset and radian will be the mode that it's in. Radian is the default. So if you try to do this in radian mode, oh, thank you. That's what you get. It kind of looks like potentially be an answer, but I'm in radian mode. So be cautious of that. All right. What is, what was it though, when you're in degree mode?
162.
Confirmation?
Yes.
And my units, which is meters. So that'll be my answer to part A. So far, so good?
Yes, ma'am.
Then it says the plane took off from a point T, which is 250 meters from where Gunter is standing, as shown in the following diagram. Using your answer from part A, calculate the angle ATH, the takeoff of the plane. So you're trying to find ATH, which is this angle right here. Remember, whatever letter's in the middle, that is the vertex of the angle. All right. Only downside is in this triangle right here, I only know, or at least right now, I only know that 350. I need another side length in order to find that angle.
You subtract 962, well, the whole number of that, and you subtract it by 250.
Exactly. I need to subtract 250 from my answer from part A. And let's say you got part A wrong, still use it. Follow through points, okay? Still use it. So let's say you didn't get that, still use your answer from part A. What is that length?
7, 11, okay,
7 what?
212 around.
So in order to find theta, I'm gonna have to use another trig ratio. Which one? I need to do tangent, not reverse tangent, but inverse tangent. Okay, but I'm gonna set it up. That's tangent of theta equals 350 over that decimal that's in your calculator. This is where you would do the inverse because I'm looking for an angle. So I would write tangent inverse of 350 over 712, and I would find theta. Confirmation? Did it tell me to round this one to the nearest whole number? So then you don't assume that you're following it throughout, okay? It bolded it in part A, which means that you needed to emphasize the fact that you need to round that to the nearest meter. But in B, you'll do to 3 significant figures. Then moving away from right triangles, sine rule, cosine rule. That was used when you had a non-right triangle. So when a triangle is not right, you can use the sine rule or the cosine rule to find angle measures or side lengths. Both of those formulas are in your reference booklet. You just have to know how to use them. Now, what I told you guys back in the day was that see if you can use cosine rule, because cosine rule only worked in 2 instances. Anybody remember?
Cosine?
Yeah, when would I use cosine rule?
When you know all 3 sides and then 2 sides and a quarter angle.
This is when you would use cosine rule, when you knew all 3 sides. So if you were given a triangle, you knew this was 7, 8, and 9, you would use cosine rule to find the angles. Or if you knew 2 sides and an included angle, that means you knew this one was 13, this one was 21, and then the angle between them you knew was 102. That is what it means by an included angle. The two sides, the angle of the two sides that you know form, that's the included angle. We'll use cosine rule for that. Any other situation, you would use sine rule. Okay? How many degrees are in a triangle?
180.
And so you will want to make sure that you keep that in mind, because if you ever had to find all the angles in a triangle, you will want to use, sine or cosine rule to find two of them, and then add those two up, subtract from 180 to get the third. True bearings and compass points. This came with the applications of sine and cosine rule. True bearings was when you represented an angle with 3 digits, okay? So let's say like you were, a car was traveling at a bearing of 50 degrees. It will be written like so. So if a car is traveling at a bearing, bearings always came from a north direction, heading clockwise. So you would start with an imaginary north line, and then you would head clockwise for 50 degrees. So your 50 degrees would be there. This is the car traveling. And then let's say the car realized it was heading in the wrong direction and then went on a bearing of 145 degrees. You use 3 digits to represent the angles. So from where that car stops, again, you have another imaginary north line heading clockwise to represent that 145-degree angle. How far was the car from where it started? There's your triangle. But bearings essentially, again, come from a north direction heading clockwise. And then that's where the angle belongs. All right. Compass points. That's north, east, southwest. Go from there. All right. There's not much more I can say about that. You need to know how to find the area of a non-right triangle. To do this, there was that formula. A equals 1/2 AB sine of angle C. This is when, if you knew this information right here, you could find the area of this triangle because you have A, B, and then the included angle. It doesn't have to necessarily be AB sine C, but that is in your, I think that's the one that's in your reference booklet. But it could be any two sides and an included angle. It doesn't have to be A, B, and C. You just got to be able to alter it from there.
Can the angle be anywhere?
If you want to use this formula, the angle has to be in between the two sides that you know.
Side angle, side.
So side angle side, yeah. So this is for, yeah, that's side angle side. But don't forget, you also got 1/2 base times height. You can always default to, but that only works for like if you have a right triangle. ABC is a triangular field on a horizontal ground. Triangular field on a horizontal ground. The lengths A, B, and AC are 70 and 50 meters respectively. And then the size of angle BCA is 78. Everything is labeled in that diagram. Now it's asking me to find the size of angle ABC, or in other words, angle what? B. Taking a look at this triangle, am I going to use cosine rule or sine rule? Very good, because remember, cosine rule is for side, side, or side, angle, side. This angle 78 is not in between two sides that you know. So right now, I want you to use the sine rule, set it up, and find the size of angle ABC. When you are using law of sines, law of cosines, the angle is always opposite of the side as well. So angle A is opposite of side A. Angle B is opposite of side B. Angle C is opposite of side C. So Just in case you forgot, that is what it is. So to find the size of angle ABC using the sine rule, I would use the part of the formula that says B over sine angle B is equal to C over sine of angle C, because I know the information about my C's and I'm looking for angle B. So then how would I set this up using the formula?
50 over sine of B equals 70 over sine of 70.
So then to solve this, I would need to what?
Cross multiply.
So that'd be 50 sine 78 equals 70 sine angle B. What would I do from here?
Divide 70.
Because I'm trying to solve for angle B. And then and with along with what?
With the inverse of sine.
With the inverse of sine. Remember, anytime you're looking for an angle, you do the inverse. So that's how I get rid of the sine. So sine to the -1, 50 sine 78 over 70, and then that'll give me the size of my angle. What did you get?
4.3.
44.3. Questions on A? So then it asks you to find the area of the field. Well, in order to find the area, I am going to have to use 1/2 AB sine C, or 1/2 BC sine A. I have to use the fact that I know these two side lengths, or I'm going to be doing more work to try to find another piece of missing information. So if I use this formula, or I'm sorry, if I use that angle, not this formula, that angle, then I would be able to find my area very easily. So you can alter the formula for the area of a triangle based off of what you have. I have side B, which is 50. I have side C, which is 70. I just need angle A. How do I find angle A?
You add 78 and the angle you got for B,
Uh-huh.
and then you add those together, and then you subtract them to 180.
I do 180 minus 78 and angle B to get angle A, which is what? 57.7, but don't use that rounded answer. Use the non-rounded answer inside of your formula. So what's 1/2 times 50 times 70 times the sine of that decimal?
1,480.
Confirm?
Yes.
Then it says M is the midpoint of AC. Well, if M is the midpoint of AC, what's the length of AM?
25.
Very good, because it's half. So how would I find BM?
We use the law of cosine.
I will use the law of cosine. Why the law of cosine?
Because you're looking for the sine of that angle. So angle A,
Mm-hmm.
and you have a side angle height.
Sure do. Because you found A to be that 57.7 number. So then you would use the law of cosines to find BM. Law of cosines, am I using that long one or the fraction one?
We're using the wrong one.
I am using the long one. I'm looking for A squared, which is BM technically. So that is A squared equals b squared plus c squared minus 2b c cosine that non-rounded answer that you got earlier. Then to actually find the length, I have to do what?
The square root.
The square root. You guys know you can type this entire thing into your calculator, right? The whole expression in your calculator. So do that and let's find the length of BM.
I got 1,080.
Let me get confirmation. So no confirmation on this. Oh, Jesus. There we go. It's actually 60.5. And then don't forget your units. Now, remember, this is a paper 2 problem, first off. Remember from before it said that ABC is a triangular field on a horizontal ground. So then for part D, it says a vertical mobile phone mass TB is built next to the field with its base at B, a horizontal ground and a vertical pole. The angle of elevation from M to T is 63.4 degrees. N is the midpoint of the mast. Calculate the angle of elevation from N to M. You have to visually be able to understand a horizontal ground and a vertical pole make a what angle at B?
Right.
It makes a right angle at B. So you have a right triangle inside of this problem that we've been doing law of sines and cosines with. TB is that vertical pole and BM is that line that's on that horizontal ground. So you have a 90-degree angle here. N is the midpoint of TB and the angle of 63.4 is here. Didn't we find BM already?
Oh, yeah.
It was that 60.5 number that's still in our calculator. So if we're trying to find the angle of elevation of N from M, I am probably going to need another piece of information in this triangle. What do you think?
Would it have to divide 63.4 divided by 2 because I missed the midpoint?
That I cannot confirm 100%.
Is it like, are you doing 2T or to M, to N?
The angle you're trying to find is this angle of elevation right here. But 63.4 is the angle of elevation to T. Now, can you cut it in half? Because N is the midpoint. I can't be 100% sure about that. I do know that I could probably confirm that if we did it essentially the longer way by finding TB, finding NB, and then finding that angle. Yeah.
The other answer was supposed to be 60.4, not 60.5. I put 15.
All right, we got to make a correction. We do have to make a correction. From part C, we should not have used 50 inside of the formula. We should have used 25. Drew it out. But when I set it up and started talking, I put 50 instead of 25. So let's make this correction before we go back to part D. So this should be 25 here, and this should be 25 here because we're using the smaller triangle of A, B, M. That is going to affect our answer to part D, so we do need to fix it. So let's go back to part C and let's find what BM is supposed to be. I have an answer, but we need to confirm it. So it is a slight difference. it is actually 60.4 meters. And because I do need to use that for the next part of this problem, good thing we caught it before we did D in its entirety and then had to make the change. So let's find the answer to this question. We know, again, horizontal ground, vertical pole, right triangle. I don't know for sure 100% if we can just split the angle in half and say it's half of 63.4. But what we can do is we can use SOHCAHTOA and find TB. If I'm going to use SOHCAHTOA to find TB, which trig ratio am I going to use, sine, cosine, or tangent?
Tangent. Not easy.
Tangent. I don't have my hypotenuse. TB is my opposite side, and BM is my adjacent. Again, we are not using the rounded answer here. We're using that extended decimal that's in our calculator. So TB is equal to that longer decimal times the tangent of 63.4. Am I good? Have I made any mistakes yet? What did you get? So we got 121. That's the rounded answer, right? Okay, but since I have to continue to use this decimal, I'm going to not round it. Remember, the more you round, the further away you're getting from the correct answer. So we have these calculators that allow us to keep these decimals in our calculator, or we can always write down multiple decimals. Final answers, though, should always be 3 significant figures. Final answer should always be 3 significant figures. But we use the non-rounded answer if I have to continue to work with it later. So TB is 120.7. How do I find NB? How do I find NB?
N is supposed to be the midpoint?
N is the midpoint, so I just divide my TB by 2. And again, that's sitting in your calculator, so just divide it by 2, and you get what?
60.4 rounded.
60.4 rounded. So we're going to keep that decimal because I'm looking for that angle. Now, again, I did not just split 63.4 degrees in half because I'm not 100% sure, but by doing it this way, we'll know for sure if we can do that in the future. So to find this angle theta, what the actual question is asking me to do, I'll have to use what? To find theta. This is a right triangle. 60.3 is my what side?
Cosine rule.
Not cosine. Rule. I'm looking for that angle theta.
You're still going to use tangent.
I'm still going to use tangent, SOHCAHTOA tangent. Because that 60.3 number is my opposite, and then that 60.4 number is my adjacent.
But if you're solving for an angle, it has to be the
Yes, because I'm looking for an angle, I am going to use the inverse. So theta is the inverse of tangent 60.3. These non-roundeds. It's what? Got 45? 0.0? And that is not half of 63.4, so we can't make that assumption.
Well, I added everything, all the numbers, and I got 45 exactly. I put all the numbers there and I got 45 exactly.
I got 44.956. Arcs and sectors is the last bit. The length of an arc and the area of a sector. Pull them straight from your reference booklet. Theta over 360 times 2 pi r, or theta over 360 times pi r squared. Arc length is essentially the perimeter or part of the circumference. But area is actually like the piece of slice of pizza, okay? That's actually the area. So again, both of these formulas are in your reference booklet, pulled straight from there. Theta has to be in degrees. And of course, R is your radius. Your angles are always going to be given to you in degree, so you won't ever have to worry about converting. But just in case, to go from radians to degrees, you essentially will multiply your radian by 180 divided by pi, and that's how you get to degree. Okay, I went over that last year because a lot of the problems that I could find that dealt with arc length and sector gave you the angle as a radian versus a degree. Okay, you know, with the changeover curriculums and things like that, you know, you guys shouldn't have that issue when you actually sit for your test.
Do we change your mode to radian?
You do not change your mode to radian. You leave it as degree. You leave it as degree. All right. So let's go ahead and convert. Can somebody do 1.3 times 180 divided by pi and tell me what that angle is? $103.
74.4.
No, sorry, I accidentally.
Okay, so was it 70 what?
74.5.
Okay. Go ahead and do that in your calculator so you can have it there. Because as you can see, I pulled this one from an older curriculum that has it as a radian. Again, you guys will be dealing with the degrees, but it's good to know how to convert from radian to degree. So when it asks you to find the length of arc ABC, it's asking you for the length. So then you'll need the formula theta over 360 times 2 pi r. Theta is that 74.5 number you have in your calculator, divided by 360 times 2 pi, what's my radius? 3. So I type that into my calculator to get our answer for arc length. 3.9, as did I. Length is always measured in units. Area is always measured in squared units. So then part B, it asks you to find the area of the shaded region. How could I find the area of the shaded region?
You would just do the sector area and then subtract.
There would be theta over 360 times pi r squared.
But my question is that how could I find that area of the shaded region when I don't know the angle of the?
Well, you could just do, since it's all 360, you would just do 360 minus the 74.
Exactly. 360 minus the 74.5 number will give me the angle of the shaded region. So you would need to do that. So 360 minus that 74.5 number, the non-rounded, of course.
285, well, 286, that's rounded.
286 rounded, but we don't want the rounded, so we just keep it in our calculator. So that's what's going to go in for theta, and I'm going to do multiply by pi r squared because I'm talking about sector area. So that's the 285 number divided by 360 times pi 3 squared. rounded. So 22.4 centimeters squared, and that would be the area of the shaded region. You could also find the area of the non-shaded region and then subtract it from the area of the entire circle. So you could do that as well and get the same answer. But don't forget, it's a circle. 360 degrees is in a circle.